Good afternoon, everyone. My presentation today will be an overview of current Ontario Geological Survey activities in groundwater geoscience. The focus will be on our main projects and activities at a fairly high level, and further details on some of these projects will be given through other presentations by OGS staff during this open house. I will start by giving you a brief overview of the OGS, our core functions, followed by a description of the groundwater initiative and the three mapping functions performed within it. Those being 3D sediment mapping and hydrogeological characterizations, 3D bedrock mapping, and ambient groundwater geochemistry. And finally, I will have a few examples of success stories we have documented for each of these activities. The Ontario Geological Survey was established in 1891 and celebrated its 125th anniversary in 2016. This year will be our 130th year of existence. To fulfill our mandate, we document, collect, interpret, and disseminate geoscience information to support and enhance public health and safety and economic prosperity. The core functions of the OGS are geoscience mapping, geoservices, which includes our laboratory and publications group that releases our data, maps, and reports, frontline geoscience expertise through our Regional Resident Geologist Program, otherwise known as the RGP, and supporting the marketing of Ontario's mineral investment opportunities and geoscience applications. The OGS Groundwater Initiative has its roots in the three main activities, which feeds into many branches of stakeholders and policy issues. These activities support decision-making and science-based policy development around many issues at other provincial ministries, shown at the top of this tree, many of which relate to public health and safety. We also aim to support municipal and private industry clients with data, maps, and reports relevant to their goals within the water, resources, environmental, and planning regimes. Performance indicators include measuring the success of our activities by tracking the impact it has through client surveys and often direct feedback from clients that relate success stories to us, whereby our work has materially resulted in substantial savings of effort and money. The first activity I will talk about is 3D sediment mapping and hydrogeological characterizations. 3D sediment mapping was initiated in 2003 and has since covered about 18,000 square kilometers, mostly in southern Ontario, in places with the highest population density or areas destined for future population growth. Studies in blue are completed and those in red are in progress. Note that the Oak Ridges Moraine area was a joint GSC-OGS effort. The objective of 3D sediment mapping is to characterize the geometry and hydraulic properties of the sediments that form regional aquifers and aquitards. Many activities contribute to the development of 3D geological models of the glacial sediments that overlie the bedrock. These models provide information about where groundwater is stored and where precipitation is entering the groundwater systems. The identification and increased understanding of the storage and recharge areas for Ontario's groundwater is essential to protect the future of this critical resource. And our work has been instrumental in supporting regional scale groundwater studies in Ontario and has supported municipal source water protection modeling. Our current active 3D sediment mapping projects are Niagara Peninsula, being undertaken by Abigail Burt. Note she is giving two presentations, one this afternoon and one on the afternoon of February 18th. Then we have Central Simcoe County being undertaken by Riley Mulligan. He is also presenting on February 18th. And the City of Ottawa in Eastern Ontario, another project undertaken by Riley. He is in the very early stages of this project, having done some recon fieldwork in 2019, but fieldwork efforts in 2020 have been delayed due to the pandemic. A relatively recent additional activity at the OGS has been the integration of hydrogeological characterizations, both physical and chemical, within seamless 3D models to provide value-added support and additional mapping products for clients faced with groundwater-related questions. Elizabeth Preeb, pictured at the bottom here, bottom right, began this activity about 5 or 6 years ago with work in the Silurian bedrock of the Niagara Escarpment, with methods development to validate this approach. Elizabeth's current project involves taking this approach of regional groundwater systems mapping to Simcoe County, where much previous work has been completed or nearing completion. Elizabeth gave a talk earlier today on the use of tritium in groundwater mapping. The 3D bedrock mapping activities were initiated in 2008 with drilling and bedrock mapping in Silurian strata, followed by groundwater-specific investigations to understand groundwater movement and chemistry. This activity is conducted to characterize large-scale groundwater systems in the bedrock. The identification of karst features in carbonate bedrock is also part of this mapping, as it can control both quality and quantity of the groundwater in southern Ontario. Much of the knowledge gained through this work has gone into the development of the 3D Paleozoic block model. Beginning in 2015, the OGS collaborated with the Geological Survey of Canada, the Oil, Gas and Salt Resources Library, and MNRF to produce the first 3D Paleozoic block model for southern Ontario. Co-published with the GSC in 2019 is OGS Groundwater Resource Study number 19. This figure shows an oblique view of the block model, for which we are providing ongoing support and development through the efforts of Frank Brunton and Key Young. Both Frank and Key are co-authors on a presentation on day 2 of this open house, to be given by Shui Sun, which focuses on the porosity and permeability variations within Silurian dolstones of the Lockport group. As I mentioned, karst mapping is another important component to understand the groundwater systems. In 2005, the OGS initiated a project to produce a karst map for southern Ontario. The map and accompanying report were published in 2008 as Groundwater Resources Study number 5, authored by Frank Brunton. The simple 3-color scheme of this map highlights the variable nature of karst features in southern Ontario, thereby assisting land use planners and hazards lands policymakers to integrate karst forms into their planning documents. Much new information and insights since 2008 has prompted the need to update the karst mapping in GRS5, which is a current and ongoing project of Frank Brunton's. The third component of the Groundwater Initiative is the Ambient Groundwater Geochemistry Mapping Program, which was initiated in 2007 and has since seen the collection of over 2,500 samples of untreated groundwaters at more than 2,100 stations across all of southern Ontario. The goal of this activity is to understand the relationships between geology and groundwater chemistry. The project consists of the collection of groundwater samples primarily from bored domestic wells, usually at a density of about 2 wells per 100 square kilometers. This program was extended into northern Ontario in 2016, with coverage currently spanning from Manitoulin Island to Mattawa. This figure illustrates the general flow from sample collection to final report and data deliverables. Every sample record contains a wealth of information, approximately 134 parameters that describe the water and its chemical constituents. The digital dataset and maps were released for all of southern Ontario in 2015 as MRD 283. Results from this sampling have identified previously unknown chemical trends in Ontario's groundwater, and one of the outputs has been Groundwater Resources Study number 17, in which 13 aqueous geochemical hazards were mapped across the province, mostly related to geology, and levels were compared with drinking water standards. Both the southern and northern ambient groundwater projects are active and ongoing. Stu Hamilton is putting the finishing touches on an updated Southern Ontario data release, which will be known as MRD 283 revision number 2, and is also working towards several more reports to support this groundwater database. Hopefully you all took in Stu's keynote presentation earlier today. The Northern Ambient Groundwater Project is also actively ongoing, and a Northern Ontario database will be published by Kayla Dell, and Kayla also presented on this project earlier today. So, as I mentioned at the beginning of my talk, we measure our program success by keeping track of how our work benefits clients. In this example, from the 3D sediment mapping activity in Simcoe County, the township of Clearview benefited from the 3D mapping efforts of Riley Mulligan. Our 3D sediment modeling, regional geophysics, and sediment drilling led to the identification of a previously unknown and untapped groundwater aquifer. The township has since begun the process of bringing a new well online. This example relates to our 3D bedrock modeling activity. The town of Shelburne lies within our Paleozoic mapping study area along the Niagara Escarpment. The town experienced naturally occurring elevated arsenic levels in their municipal supply wells, approaching drinking water limits. Frank Brunton's work in the development of the regional sequence stratigraphic framework enabled the targeting of deeper groundwater flow zones with adequate quantity that do not contain the arsenic-bearing minerals impacting the established water supply. This water supply is now online and has saved the municipality millions of dollars in water treatment costs. And finally, this example is from the Ambient Groundwater Program. This figure illustrates one of the potential public health hazards that was mapped as part of GRS 17. A major issue in Ontario and many other cold places is the rising chloride levels in groundwater, often attributed to the use of road salt. This figure shows the chloride levels across southern Ontario, with hotspots shown in yellow. Through interpretation of salt ratios and an understanding of lithogeochemistry of the source rocks, we see road salt impacts, but also the natural influence of the glacial marine Champlain sea deposits in the Ottawa area and Paleozoic bedrock in south central and southwestern Ontario. This mapping that identifies excessive chloride from road salting assists water supply and road salting decision makers across the province. So this concludes my quick summary of the primary and current OGS groundwater projects. And here is a listing of the OGS groundwater team, should you have any questions. And these folks will be available today and on Thursday during the open house, and of course are available almost any time via email. Thank you, and happy to answer any questions.